Hi, this is Adam with Makerspace, and I'm here with our first webinar for the Maker Fellows program. So in this webinar, I'm going to talk about your Scratch startup, the Great Race, and just your general first Makerspace experience. Okay, so your first Makerspaces, first of all, it's not mandatory for you to start this week. So if you are starting this week, that's awesome. If you're not, that's okay. But definitely be recruiting and moving towards starting up in the next few weeks. Okay. It's helpful to consult your Makerspace checklist as you're getting ready for this. So your checklist, again, is just going to have all the things that you want to do before, during, and after your Makerspace to make sure that you're prepared and have a successful Makerspace. That starts, of course, with prepping in STEM Collab. And if you're watching this video, you're probably doing an awesome job of that already. So kudos to you. And for you, that's going to include building this Scratch project, which you've already done a version of in the training, but it'll be helpful to just refresh yourself in Scratch and maybe try building this project once more and just seeing what sort of roadblocks you hit, right? Then you're gonna have to prep your Makerspace and technology. So you're gonna use computers for this, which means that you're gonna need to make sure those are charged, make sure your internet is good for that day. So those are things you definitely want to be aware of. You have some supports to print, so that includes a rubric, a challenge report, and we're going to talk about where you can find those in just a minute or two. And there are no other documents for this challenge, so just those first ones. And then take your attendance, facilitate your Makerspace, which we have all your instructions for in the lesson plan and in the other video, though we're going to talk about some of that stuff more in depth in this video as well. Monitoring, using your rubrics to encouraging your students rather to use the rubrics to track their own mastery of these skills as they complete these challenges. And then finally sending your students home with their challenge reports, and then coming back here to the STEM Collab to share some of your experiences, doing your quiz in the STEM Collab and doing your prep and practice prompts for the lesson, okay? And just as far as other physical materials you want to be aware of, your design cycle poster, your badges, your magnets, you want to make sure you bring all of those with you so that you can use them in your Makerspace, okay? And so in your first Makerspace, you're going to want to spend a few minutes introducing the idea of a Makerspace to your students and just talk about what is a maker and what is a Makerspace and why are you all going to be spending this time together, once a week for the rest of the year after school, right? What skills and processes do makers use? So this is a good moment to introduce the engineering design cycle, this process through which real engineers and real makers build products and solve the world's problems and do all the other amazing things that they do, right? Which is a good segue to talk about the other Makerspace protocols, including the use of magnets, team magnets to move around the circle, how teams should, look back to see what other teams they can collaborate with and bring forward in the cycle, the use of badges and rubrics, and how all of these things tie together to create this Makerspace experience, okay? And you might also want to just take a moment to introduce the idea of computational thinking to your students. You don't have to go super deep into it, but just the idea that as we learn how to program and work our way through these technologies, that we're going to face different problems, specific problems that arise when people use technology, and there are specific skills, computational thinking skills, that we want to use as we encounter these problems that will make us better engineers and better makers, okay? So I'm going to link the video that we showed in training below this video, and you can check this out. You can check that video out and show it to your class, rather, if you think you have enough time, if you think it's a useful use of your time, okay? So Scratch Basics, the Great Race. So the materials you need for this are your charged computers, your internet access, optionally your paper Scratch blocks, which can be useful for just introducing the idea of block programming to your students, and then the rubric and the parent report, which need to be printed ahead of time, one per student, okay? So your discover phase. So you're probably already in some sort of a circle briefing if you've been talking about introducing your Makerspace and your goals for your Makerspace. But at this point, you can shift gears to talking about this specific project and talking about Scratch. And at first, it might be helpful to start from a high level and just ask, what is a computer program? So you can discuss this think, pair, share style between students, or just as a class discussion. But what is a computer program, and what does it mean to write code, and why do we program computers? What do we want computers to do for us, right? How does the code we write make things happen on a computer? And as you're doing this, introduce your STEM idea and your keywords for the day, and introduce Scratch and the project editor interface. So, your students have maybe some of them have used Scratch, but for the most part, they've probably never heard of Scratch before. So just make sure you go through the interface as a whole, show them the different parts of the project editor, sprites, backdrops, scripts, stages, right? All those elements and how they work together to create the projects that we're going to create in Scratch, okay? And optionally, you might want to do a quick exercise with your printed Scratch blocks that we used in our training, just to introduce the idea of block programming as you start to talk about scripts. Each block represents a different function, and these functions can all be linked together to create larger script chains that will create our programs and that will run our programs the way we want them to be run. Okay, so that's what we're doing with blocks, and that's what a block programming language is, where we're writing with blocks instead of your dark screen with green matrix code all over it. Now we're just using these fun, colorful blocks. We snap them together, and that's our code. And at this point, I want to take a minute to shift gears over to first the STEM collab and then over to Scratch. And I want to show you how to properly set up your Scratch classrooms and how to get your students into Scratch. Okay. So here, first of all, I just want to quickly point back to our collab page here for The Great Race, and specifically to this links to challenge materials section right here in the center of the page. Lesson plan, Scratch project prototype. So this is my project prototype. If you want to look at my version of this project, here's a really easy way just to get to it. And you can click see inside to get to my scripts. Okay. This lesson plan is kind of your step-by-step written up lesson plan, a lot of which I'm kind of talking through right now, to be honest. But here's your written step-by-step plan on how to approach delivering this, with all of your background information, keywords, and ideas up here in the top. We have some images that you can show to your class. This is just a nice kind of Scratch overview diagram here. Some background information, and then finally your design cycle instructions with your highlighted checkbox moments. So just be sure that when you're getting to one of these moments, you urge your students to go to their rubrics and check their corresponding boxes and make sure they're assessing themselves on these skills as we go through. Okay, so here are your step-by-step instructions, and these also appear in the other video that's already in the STEM collab. This one right here is again all about just me building this project from the ground up. So if you want a refresher on some of those things, you can go back there or read through them here. And then eventually down at the bottom, we have our improve, our play testing directions, and some guiding questions for that. And then also just some extra challenges, ways to bring this challenge further. We'll talk about that a little bit later. But what I really want to show you is, so we have those two things, and we have the rubric, and we have the challenge report, both of which are linked right there. So just print those and hand them the rubric to your students at the beginning and the challenge report at the end as they leave. Okay. So anyway, what I want to talk about is how to set up the Scratch classes. This is something I feel like we didn't quite get to cover deeply enough in training, but hopefully you've all requested your teacher accounts. And if you have, then this is what your homepage will look like. And you can go to My Classes, which is where you'll store your class or your classes. And if we just make a new class here, we can call it, Maker Fellows Test Class. Okay, we can add a class like so. So here's my class. You can write your description here and what is your class working on, and then we can go to students. And obviously the next step here is getting your students into this class somehow. And there's 3 different ways to do it. As you can see here, we can add students one by one by clicking on this and then creating a username for our students and typing that username here and submitting it. I find that way to be a bit tedious, and it means you need to come up with all the usernames yourself, which maybe you don't mind doing. But what I prefer to do is to send a student sign up link. So what this button does is it will generate a URL that your students can click on. If we just copy and paste this into a new tab here, this is, if your students go to this link, they'll be invited to join your class. And if they go through all these steps here, etc., right, they'll end up as students in your class. Now, the thing is, this link that we generated here is very ugly and hard to type, and you would never ask anyone to try to type this whole link in. So if you have some sort of school email system and you can email this link to everyone, that's really easy. What I like to do in, cases which that you don't have that option is use one of many tools to create a smaller shortened URL that your students can type. And for me, I like to use tinyurl. So let me just show you how to do this quickly. tinyurl.com. And all tinyurl does is it takes your super long, ugly URL and turns it into a nice, small, short URL. So if we say, tinyurl.com/makerfellows scratch. That's not that short, but you can, if you're at a school, you can do PS 100 scratch or whatever it is, and make your tinyurl, and tinyurl reports back that our URL has been shortened successfully. So now all a student needs to type in is tinyurl.com/PS100 scratch, or whatever. I just use that as a generic extension, but you can type in whatever short extension you want there. Now, if we go into a new tab, we go to tinyurl.com/PS100 scratch and go to that. Here we are back at this same sign up link. So that's a really helpful tool, honestly, in general, for using Scratch and some of these web interfaces for programming, just to shorten links. But definitely for this instance, that's a really helpful tool. Your third option for getting your students in is to do a CSV upload, which I haven't really done too much of, but if you're savvy with Excel and using CSVs, which are comma separated value files, you can actually upload all of your students into Scratch at once, which is perhaps the most efficient way to do it, just by creating a CSV file as this one. You can download some examples and learn more about CSV files, but the general idea is username, comma, password, enter username, comma, password, etc. for your whole class. And this is good. This, again, means that you need to come up with all those usernames and passwords yourself, which maybe is a good thing for you, or maybe you'd rather your students come up and have ownership over those things themselves, okay? So those are the different ways of getting students into your Makerspace. And once you have some students sign up, let's see if we go back to one of my other classes. Here we have one student in this class. So once you have a student here, you can go to account settings to change their password, which will be useful, especially if you have younger students. I'd definitely urge you to have your students all write down their usernames and passwords somewhere, just so that they don't get lost, when you come back next week. But definitely a good idea. And also, once you click on a user, then you'll be able to see, once they make some projects, what projects they create, what projects they share, etc. And the last thing you can do for your class is to create a studio for your class. So if you say create a new class studio, a studio is just a collection of projects. And the benefit of a studio is that, one, your students can all upload their projects there, so that you can just have them all put their projects in one place. And once your projects are in your studio, you can just add projects by clicking add projects and add them on the bottom here. And once you've added projects into your studio, then your students can easily see those. So if you wanted to have an example great race in a studio ready for your students to just access it very easily, a studio would be a great way to do that. Okay, so hopefully that makes sense. There's definitely just a lot to be learned by clicking around in this teacher class interface and just learning about what your different abilities are, and letting it kind of marinate a little bit. But that's a quick overview for using the classes, using studios, and getting your students into Scratch. Okay, so once your students are into Scratch, you're ready to actually build your project, which we talk about. We have all of your instructions right here, once again, for building it, and in the other video. And then finally, after this, you're going to get to your improving phase, your playtesting phase. So This is where you can use either a gallery walk or a think, pair, share to have students give each other feedback. Again, we like to use that tag protocol. Tell us something you like, ask a question, give a suggestion for feedback, right? Or if you have a different feedback protocol that you like to use at your school, that's great. And then hopefully you have some time for your students to iterate upon their designs a little bit. And I just want to take a quick second here to maybe talk about some possible extensions and iterations on this. So I'm going to save this as a copy really quickly so I don't mess up my original. Let's say Great Race iterated. Okay, so there's a lot of things that your students might have an idea to do after completing these first steps or completing this first build. Some easy ones are playing a sound when you cross the finish line. So maybe if you wanted to do something besides say I win, you could add a sound. So let's show you how to do that. You can go to sounds quickly, choose a sound from the library, and your students will have fun clicking through these and finding something that they like. Maybe I'll just take my chances with dance space over here. How does that sound? That one's kind of creepy. Let's find dance magic. That's a good one. Okay, so I'm going to click on dance magic and click OK. And then for my sprite, I can just have my sprite play sound dance magic. And actually, I'm going to use play dance magic until done after they say I win. So let's test this. I'm going to run across with the space key, and we're going to hit that. And then there's your music. Hopefully you can hear that through my microphone, but I can definitely hear it here. So that definitely works. So there's one iteration you can do. Another fun one that I've seen students do is add another sprite to be the referee here. Maybe you want, I think the polar bear works well. You can take this polar bear, add it here to be your referee, and you could say something like, we're already using this green flag here to transport our sprites back to the beginning. That's kind of our starting button. So we can do something like have this polar bear go on your mark. Get set. Go, right? Okay, so there's just another idea. So there's many, many things that you can do this. Oh, I'm going to show you just one more before I wrap this up. So the last thing you do is right now this is a 2-player game, but what would be cool is if we made it into a 1-player game, which we could do by automating one of our sprite's movements. So maybe instead of having this sprite using this this right arrow to trigger their movement, what if we just put this inside some sort of loop? And instead of moving 10 steps all the time, so again, I'm using a forever block here, which is just going to repeat some action over and over. And, this is going to be really fast, I think, if we run this. Right. So we need to, first of all, let's make this wait until this polar bear stops, which is going to be for a total of 6 seconds, 2 + 2 + 2. So we can say wait for 6 seconds here. And then that was really fast with 10 steps. Maybe we'll go 2 steps. And if touching sprite 2, say I'm the winner. And then maybe we'll stop all after that. And now we need to race against this bug. That's actually pretty difficult. I win. Okay, so now we have this issue of both sprites finishing the race, which is a challenge I will leave for you to figure out how to fix. That's kind of the first big bug that I would say comes out of this this exercise here. But the first big bug that comes out of this challenge is the fact that both of our racers can still win the game. But here's a quick, and dirty hack to make this a one-player race. And on the subject of debugging, one more fun thing that you can bring into this if you have time, or if you have students that, have used Scratch before and need a little bit more of a challenge. In your STEM collab, you should now have a new course that is called Debugging Challenges. Maybe did I link this down here? I don't think I linked it down here yet. Okay, I'll link this down here in this challenge at some point too. But we also have a course called Scratch Debugging Exercises, which you should all be enrolled in. And these are specific debugging exercises that correlate to, oh, come on, we can definitely use Flash. Oh, by the way, if you're using Flash for the first time or using Scratch for the first time on these computers, you might get what I just had, something popping up saying, hey, you need to run Flash. And don't be scared of Flash. Flash is, a fine, verified technology that most computers have pre-installed on them. So just allow Flash to run if you ever get that bug there. Okay. And again, so here are some debug challenges for your students, and maybe something fun for you to try. And the idea here is the working version of our project, the way we left it. Here is a bugged version of the project. So in this version, there's something wrong with the code such that it doesn't work the way we want it to. Okay, so we have some problems here. So here's another challenge for you or your students to try to debug this. So this can be this can also be used as a warm-up for your next Scratch class, for example. Okay, so I just threw a ton of stuff at you for how to start your Makerspace, how to go through your Discover section. Hopefully this section on how to enroll your students in your Scratch class was useful. Definitely, give me some feedback on that if you're having any bugs or issues with that. And then on some extensions for your Scratch project, and finally how to get to this debugging challenge that you can use if you have extra time, or just to test you or your students' skills. Okay, so I hope this was a useful webinar, and I hope to see you back for the next one. So enjoy, good luck at your first Makerspaces, and I'll see you all soon. Thanks for watching.